Hello. Hello, year 9. Welcome to power. Power. What is power? I has the power. Okay, what is power? So that's what we're going to do today. We're going to hopefully get you to describe what power is, tell you what power is, and how to calculate it. Fairly simple stuff. Okay, let's have a look. Here we go. So what is power? Take a pause, have a look at these pictures. Is that Thanos there? He's got power. Yeah, but what do we mean? What is power? There's Trump. He might be in power again on Thursday Tuesday the 4th, isn't it? Gosh, yes. Anyway, so let's move on. Here we go. That Hulk Hogan, wrestler, famous guy. He looks pretty powerful. So what is power? I will tell you. Power is how fast or the rate of energy transfer. Okay. If you can transfer energy really, really fast, that means you are powerful. You can use more energy per second. Okay. Let's go back. So if me and Hulk Hogan got into a fight, he's got really big, powerful muscles. His muscles can convert energy really fast into movement, so he can use more joules per second than me. He's pretty powerful, but I reckon I could cycle my bike faster than him. Okay, so that's what I mean by power in physics. It's the rate of transfer of energy. Okay, so here's a quick example. Whoops, I've started that. Let's go back. Let's go back and talk about it first. Here we go. So we've got two cranes. They're both lifting up a 10,000 Newton weights, 10 kilonewton weights, so same amount of weights. They're going to do the same amount of work, so they're going to use the same amount of energy in lifting them to the same height, but which one's more powerful? And here we go. If you raise it, let's have a look. I'm guessing that all of you are saying that one on the left there is more powerful, which it is. Okay, it's done the same amount of work as the one on the right. Whoops, I wanted to start there. It's done the same amount of work, so they're at the same height, but it's done it quicker. It's transferred energy faster. Okay? So that's what we mean by power. So here's a nice little definition. Power is the rate at which work is done. And here are some more examples. Here are two airplanes. Which one's most powerful? It's the one at the top. It's a jet engine. It can convert energy much, much faster. Okay. And so it will go faster, it will accelerate quicker, and so on and so forth. So how do we calculate it? Very simple. We need to know the work done, how much energy has been transferred. We need to know how long that took place in. And then we can measure the power. We can calculate the power in things called watts. And what's a watt? A watt is 1 joule per second. And there's our formula at the top. Notice I've written it out twice as work done over time or energy transfer over time. Okay, both are correct. Both are correct. Because work done is energy transfer, isn't it? Okay. Now then, here's a note. And a cue for the first activity. 1 watt is 1 joule of energy transferred per second. Now that's a tiny amount of energy. Okay, if you got an apple, and a typical apple has a weight of about a Newton, and you lifted it a distance of 1 meter, you would have done 1 joule of work. Okay, so it's not very big amount of work. And so often in physics, we talk about, oh, there's a picture of an apple going up there. I like that. There you go. Often in physics, we use things called prefixes. So, for example, the first one is kilo. Kilo, we know, means 1,000. There are 1,000 grams in a kilogram. Or we can write times 10 to the power of 3. That's standard form in maths, which you might know about. Then we've got mega, which is capital M, which means times by million. So a megajoule would have 1,000,000 joules in it. A megawatt would be 1,000,000 watts of power. And there are some simple examples there below. Okay, pause the screen, have a look at that, look at the examples, make sure you can get your head around it, and unpause. See if you can do these quantities here. Look, now this is on a sheet that should be in Teams. If not, pause the screen and just do it. Okay. Oops, somebody's trying to get me on the mails. So I'm unpausing now, and we should get these answers here. Okay, so that's converting from one to another. So do note, for example, if you look at number 3, I would quote a number as being 430 kilojoules. I'd do that because it's much easier than saying 430,000 joules. Okay, so it's just for convenience. For example, okay, where it does get tricky, one's like number 8, where you'd say converting megas to kilos, but just write it out. Write all the zeros in and then figure it out. Okay. Good. Let's move on. Let's look at the formulas, using the formula. And here's a typical question. Here's an electric heater. That heater used 180 kilojoules of energy in 2 minutes. How powerful is it? Okay. Now we've got to be careful here, because when we solve these problems, okay, we obviously write down the equation first. I've written that down there now. But we've got to convert our values back to joules and into also seconds. Time is always measured in seconds. So see what I've done there? I've turned 180 kilojoules into 180,000 joules, and time, 2 minutes, is 120 seconds. Then I've plugged those numbers into my calculator. And what I got out was 1,500 watts, or I could write it as 1.5 kilowatts. Okay, so make sure you've written down that example, have a go at that. And I'm going to move on now. So you will have access to these questions here. There are a number of questions going from number 2 all the way up to 9, which are using the power, energy, power, time formula. There's a little formula triangle there for you if you like using those. So in the next slide, which I'm going to move on to in 5, 4, 3, 2, 1, we've got some answers. There we go. Pause it, moving on. Pause it, moving on. And the final ones, pausing, moving on. Good. Oh, there we go, the Tesla Roadster. Okay. So quite tricky. There we go. So any problems with those questions, don't get the solutions even though I've seen them now, okay? And do mail me in Teams and I'll go over them again, okay? Here we go, some true or false questions, 5 quick ones. Whoops. Which one's true, which one's false? I'm going to pause this for a minute and unpause now. There we go. It's both are true. That in fact is true. Fleas are really, really powerful. They're tiny though, but a flea's muscles, I think I researched it, you can find it out yourself. I think it's like several hundred times more powerful than a human's muscles. And that allows fleas to jump really high relative to their size. If we could do the same, we could jump to the top of a tower block or something silly. Okay, so fleas are really quite powerful. That is not correct. 125,000 watts is going to be 0.125 megawatts. And the final one, we could indeed measure energy in kilowatt hours, because energy is power times time. Kilowatts is a measure of power, hours is a measure of time. So we could if we wanted to, and there are some instances that we do. Okay then, so any issues, mail me on Teams, and oh, we're not doing that. Enjoy, and I'll see you soon.